Hello everyone. Thank you for watching my YouTube video on Kubernetes. In this topic, we are going to deal with volumes, stateful and stateless application. So volumes in Kubernetes allow you to state data outside the container. When the container stops, all data on the container itself is lost. So there are two types of scenarios, like either you call it as a stateful and stateless application. So what is stateful and stateless application? A stateless application is one which depends on non-persistent storage. The only thing in your cluster is responsible for this code other than static content is being hosted on it. There's no changing in database, no write files, no leftover files when the pod is deleted. Whereas in a stateful application, on the other hand, there's several other parameters it is supposed to look after in the cluster. There are dynamic database, which even the app is offline or deleted and persist on the disk. On a distributed systems like Kubernetes, they have several issues. In fact, like if you want to have you have to have means critical applications to be hosted, and database have to do replication. All those things has to be taken into have to be considered. So in the Kubernetes world, the volumes plays a very important role. If you have an internal service or external service, either you a stateless application or stateful application, we have to decide. So persistent volume plays a very important role. So persistent volume is a mechanism. It is a mechanism of the abstraction of a more robust storage that is tied to the pod lifecycle. Instead, they allow administrators to configure storage resources for the cluster that user creates and claim for the pod they are running. Once a pod is done with the persistent volume, the volume reclamation policy determines whether the volume is kept around until manually deleted or removed along with the data immediately. The persistent data is used to guard against the node-based failures and allocate greater amount of storage than it's available locally. In this diagram, you can see there is an external storages is coming. Actually, we can use any storage like an NFS, cluster cloud, etc. It can be any software defined storage. So persistent volume. So what is mean by a persistent volume? So persistent volume, for example, I'm administrator. I just cut an disk and present it. So it will attach it to the pod. So it can be any kind of file system. So I can be a safe, any type of storage device, like a safe, like when the software defines safe cluster of scale IO, or it can be host path. Host path is nothing but a physical machine or physical machine you are providing from. Then you have the scale NFS, iSCSI, etc. So persistent volume is basically it's created by the Kubernetes administrator. They are backend different devices like physical storage, like yes, software defined storage, NFS or iSCSI. Okay, once the Kubernetes, once you have administrator provided, it's called PV. The Kubernetes provided a special volume type, persistent volume claim, in which we define the storage requirements. For example, if you have I've allocated a 20 GB pool, then I want how much I can allocate to the pod. So on this scenario, I'm just allocating 5 GB from the NFS. Once I allocated, then it goes to the persistent volume claim, which is will talk that if you want Kubernetes will put a special volume, which is in which the storage requirements, like I want 8 GB for the pod, it will be using it can be read write once, which you mean the access from only this I will cover about the access mode. So you can allocate 8 GB and assign it to pod. So whenever you launch a pod, it will get directly space of 8 GB. So this is a method we are using at the moment. Even if you want to use like any LUN based or which is coming from a SAN based, you can allocate this method. So access mode. So coming to access mode, and there is one more thing. It's called dynamic storage. This is what you are seeing about is basically like there's two types. One is static and dynamic. Static is basically your coming host level, it is coming from the storage level. It's not from the storage level or from NFS, those kind of things. Whereas if in a bigger organization, like if you have more than 200 servers, 400 servers, like we cannot manage directly. So allocating disk is not easy, in fact. So the storage, this option called storage class, which will call storage providing. You can take any big or massive storages from like EMC, Dell EMC, or Scale IO, those kind of storage infrastructure, you can take it and you can claim and attach the storage to the directly to the persistent volume claim and attach it to the pod. And one beautiful thing is that is in Kubernetes, Kubernetes can directly take care of the persistent volume claim, and dynamically you don't need to have storage administrator. It will allocate directly, search for the nearest storage and allocate the best possible matches. What are the best possible matches of PVs? It doesn't have a PV in fact, but it will directly contact the storage class, attach it to the container, and once the container use it, and then it's reassign it back to the reallocate the space back to the storage, physical storages. Okay, so now there are volume access mode. So you will have either read write once, read only many, and read write many. So read write once means if your example you have pod and it has been attached to one single node, you can read write on a single node. And there are other options you want only read only from other nodes. For example, the pod is there and you want to have other pods want to view or read only, you can specify that. And there are some scenarios the data can keep moving to other nodes, and in that case you can move the pods. In that case we allow to write from many nodes, so that's the option. And now other option is the persistent volume binding. So when we allocate a PV, so when actually the binding will happen, so there's like they can be done through amount of storage or the access mode or through the storage cache. Binding is nothing but say for example I allocate the 20 GB file system. When you attach the volume and the volume claim was successful, then it is bound. So then it can be successfully bound. If we could not able to successfully bound, then it called not bound. Okay, so in this option, and there is also reclaim policy in the persistent volume. We will have a reclaim policy. It's one of the beautiful feature in Kubernetes that saves huge amount of cost in the storage. What happens is when I launch a pod, once a pod is launched and I'm done with my activities, and if I delete it, you can do it by manual reclamation or recycle them. Or recycle means you can scrum it out, or you can scrub it out like just deleting them, and you can specify it in your pod level itself, and you can reuse the space. So once your activity is done, you can delete them, and so that the storage space is reclaimed, and you can reutilize the storage. In the current traditional world, in the VMware world and the physical server world, you allocate a LUN and disk is, even though disk is not used, it's completely occupied. So this is one of the beautiful features that Kubernetes do provide. I've already yeah, here is the persistent volume. You can there is an high available infrastructure. You have three applications and three databases. You have web app and a DB. So this is the where critical stateful application is running. So persistent volume plays a very vital role in the Kubernetes world. So let's get into the demo. In the demo, what I'm going to show you is that I've taken a Redis storage. So the Redis storage is using the MTDIR. So MTDIR is a volume type, whether it's like a medium based, either it can be run in a disk, SSD, or network storage. Okay, so MTDR, even you can say, specify to run it on the memory or RAM based, or even TempFS. So it will be very fast, and it can only be used for any static content, and or you want to really store content, you can use it for. Let's launch it and see. Okay, so we can launch it, and I'm going to launch the Kubernetes. Yep, so kubectl get pods as a pod container is creating and now running. And let's select into the container. So this is basically a stateless type. So what you're going to do is that is we'll once the container is deleted, data is lost in this scenario. So what will happen is that is like, but this is for you can store it for anything which you want to store for dynamic content, and you want to produce a good output. You can use this option. Yeah, so you can see the file is available, and at the same time, if in this scenario, if you kill any process of the Redis, automatically the container will be deleted and recreated, and data still exists. And but when you delete the pod, data is lost. So say assume like kubectl get pods and kubectl delete pod, your data will be lost. This is the feature of the non-persistent volume. Yeah, so the pod is deleted. Now let's go for the persistent volume using a host path. So here I'm just going to use the host path. The host path is basically MNT data. So which means on each individual node, I'll be creating the data, not for master, but you can create it for the on all three nodes. Let's create it on all three nodes. Let's log in to the nodes. 168.1.72. 71.72. Okay, so let's log into other three nodes. Yeah, so we have logged into all three nodes. Let's create the local lowest bound point. So mkdir data, 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 data. Okay, let's create this from the master. However, you cannot don't need to create it in master. I accidentally created it. Okay, so let's create it in node one, node two, and node three. Yeah. So once this is done, now let's create the persistent volume. So PV volume. So we are allocating a local volume. So host path is slash MNT, storage space is 10 GB, and the name is task PV volume. Okay, now let's create that. Now so kubectl create -f. Yeah, so the volume is created now. Let's see the get PV. kubectl get PV, so you can also use get PV. So it is a read write only mode. The reason is that is we have given it here read write only once access mode. Okay, so let's launch the PV claim, which is basically what I'm going to do is that is I'm putting persistent volume claim so that the pod can take it up and run it. So let's create it. Yep, so now created. So kubectl get PVC kubectl get PVC. So persistent volume plane. Now you can see the local disk, a local source disk is mounted successfully. So we have allocated 10 GB to read write only. So the storage class is manual. Okay. So now we have successfully done. Now what we can do is that is we will launch the pod now. The pod is nothing but we are running a web server using Nginx, and that will serve the port, and you use the local mount point user share HTML from the local mount point MNT data. So let's launch the pod now. This is for the persistent volume type. This is for the you can say stateful application. This can be used for the stateful application. Let's create the pod. Okay, so kubectl create FNF. Now the pod is ready. Let's check the get pod. So the pod is creating. Yeah, so it's running. kubectl get services. Now get pod. So we are not exposing the service. Now let's log into the pod kubectl execute -it task -pod dash. And now you can see here, so curl. You can now let's before doing that. So let's get where it has been, which node it is here. -oy, which is coming from node 2. Curl localhost I'm sorry, I didn't install that stuff. I'm going to go done. I think I have to upgrade it first. Okay, so let's update it. Yeah, it's taking a minute. Yeah, now let's now done. Wow, so many packages. Yeah. Yep, you can see it is coming from the local storage. It is coming from store node 2. So that's what this is called the host method. So host volume mount files is like basically it is taking from the node file system into your pod. So this is nothing but most of the pods will be taken it from the your physical machine. Okay, so take a data from your physical machine. So now let's clean it up, or let's go for the next one. Is basically we are going to deal is about this NFS. So I've already configured the NFS server, and I've already mounted. In fact, so you can see I've already mounted it. Yeah, so I've already mounted it. So df528/NFS. So I've already mounted across all the machines. So I've given the steps how to mount the how to really create the NFS and and how to mount them. So this is my NFS server. I've allocated almost 50 GB space. So you can see here it's a 20 GB space, and I'm just going to present. This is a type which is using the path is using NFS. So what I'm going to do is I'm allocating 10 GB read write to many, which means I have three nodes. These three nodes can be used. In earlier method, we are using read only for because read only more thing is that is read write only on one node. Basically, is like you will allocate it only on one node, and that one node can be able to write. For us in this scenario, this is the stateless, stateful application. So, like I have one consistent data been writing, I can write it in a common storage mount point. So this is where I'm using it. So let's create it. So what I'm doing is the server. My server is I think my IP address is different here. So let's start. Okay, so let's download it. Okay, so NVC PV. So what I'm going to do is that it is going to come from my NFS server. So NFS dot rmohan.com. So what I'm going to do is that I'm going to do it, and I'm going to create a folder NFS NFS P1 PV1 PDIR NFS PV1. Okay, so now it is created. Now let's check df cd NFS PV1 slash NFS PV1. Okay, so we have created it successfully. Now let's launch the pod now. So our pod is created and NFS PV1. Now let's create the physical volume. So physical PV. Let's create the PV. Okay. So kubectl kubectl create create hyphen f NFS PV. So now the persistent volume is created successfully. Now next we are going to create the PVC. On the PVC we are specifying, as I already said, it is a read write many, which means for multi-node, and read write once is only for one node and read only for multi-node. Okay, so now we are going to create the PVC. Yeah, so kubectl get PV. Now we can see earlier we add the physical. Now we add an local volume and physical. Now NFS volume both are mounted, and this is storage is manual. Okay, so and let us take some time to populate this value. Now both you can see read write X and read write only. Read only no, one single node. Okay, now let's go to launch the Nginx. On the Nginx, what we are going to do right now is that is we are going to mount onto the NFS. Okay, so let's mounted. Let's create it. Yep. So we have created it. kubectl get pod. So the container is creating pod -o watch -o wipe -watch. Mm. Okay, so the container is NFS container is still creating. Let's clear the screen. Yeah, so the new image, I think it's downloading because it's downloading from the Docker images, Docker registry. Yeah, so the container is up and running. So let's kubectl. Okay, exe hyphen it nginx nfs plus dash. Okay, so curl http colon local host. Oops. Which path is it? 1 minute. Okay, let's get into the pod. Get pod. Okay, what is IP? Oh, it is giving forbidden 403 forbidden. I think I have to look into this issue. So, however, it is definitely since it's mounted to a user, and let's check into the mount point. So let's get into user HTML because due to the okay, the main major problem what I did is that is I have not created the file. Now let's access it. Yep. So you are able to get the persistent volume and you can expose this and access it across any server. Or so this is what does the persistent volume stateful application setup also. I will try to make a demo on the stateful and stateless application. In stateless application right now, I am trying to create and deploy a PHP guestbook application. Okay, so it is basically a stateless application. There is no persistent volumes, nothing. It is like I will use the it will be temporarily be there, mainly on stateless app like non-persistent data. So it will use Redis. It will have master one master and two slaves. Before the let's clean up. Let's talk about that in next video. I will pause it now. Thank you all. So in this thing, we are going to deal with the stateless application. I'm going to deploy a guestbook application which is using a Redis. So what is happening is that this we will have a Redis server, one is a master and two slaves. So we are configuring one master server and two slaves. So the data will be means there will be we are deploying an application. So there's an PHP based application. That PHP application will be an it will be in static. It's not a, it's a static content. However, it's a non-persistent storage. We are deploying it in the non-persistent storage. So we'll have a three front-end service, and we'll have one PHP application which will be served with one master Redis and return to the two slave Redis server. So let's launch it, and we can access it. So this is one example for a stateless application. So first we will create the master Redis setup. So you can take it from my GitHub repo. So kubectl get pods. So you have the Redis master is ready now. Okay, so Redis master is ready now. Now next thing is that is we are going to configure the slaves. So let's launch the slaves. So one slave is ready. kubectl get pods. Oops. I'm sorry, so it's created a master only. So now let's create the slave deployment. Yeah, so one master, two slaves. So the master will talk to the two slaves and the data has been exchanged. Okay, the master will send it to the slave servers. So the two slaves, it will keep one is read write, others are read only. Okay, so now let's launch the Redis service. Previously, we launched the master service, I believe. Yeah, so kubectl get services. Yeah, so when Redis master is running on 6379, now let's launch the slave service. So that is also in a container talk to 6379. Yeah, so get service. Slave deployment. Let's launch the Redis slave service. Backend port is 6379. Okay, so kubectl get services. Okay, now master and slave is ready. So let's see. Okay, I don't have telnet. Yep, telnet. I don't have telnet. No worries. So now we are going to deploy the guest application. So one is called front-end deployment, which is using PHP, PHP based application. Let's deploy this application. So you can view how I have deployed it. Okay, so let's deploy the application. Let's launch the pods. So kubectl get pods. Yeah, so I've created a 3 copy of a PHP application. Now we have the application. Let's and it is talk to the master server. Now I want to expose this front end application. Let's expose this service. Okay, let's expose this service. Okay, so HTTP read stateless icon front end service. So what I'm going to do now is this. I'm going to apply it. So kubectl get services. Okay, now what I'm doing is that is I'm exposing it to the external world for the two IPs. Let's access that IP. Alright, so let's get into the thing. See, you are able to chat, submit. You can do all the static data. So similarly, 192.168 1.70. See, the data is been getting populated. So if I'm right now typing this data, it's just a stateless application, but our performance will be literally faster. So you can see. So this is one good example of a stateless application. In similar fashion, we can. I will also add a for a stateful set. The stateful set. I'm just going to launch the. I can show you what I'm going to do right now. So. Um, uh, so I'm going to create an NFS mount point. So similarly, which I've showed you for the I've showed you for the PHP I've showed for NFS persistent storage. Similar fashion, I'm using this as a volume type is NFS type. So here I'm going to deploy a persistent storage. I'm using MySQL database and the WordPress. Okay, so here I'm trying to use the first I've allocated from my storage. Okay, I've allocated it. Now let's create the persistent volume claim. Okay, so persistent volume claim is what is basically, oh, sorry. So using thing, I'm read write once, I'm allocating 5 GB for my application WordPress. Now let's me deploy the WordPress. Before that, you can view it. So what I'm doing is I'm going to launch WordPress application tier to MySQL, and I'm going to I can pass the MySQL password in my secret. I've already configured it, so it will take it up and run it on. So let's create it. Oops, I think I've already created them. Yeah, so already PV claim is already used. Let's delete them. Okay, now let's create it. Yeah, so kubectl get pods. Okay, now see the MySQL, you can see the WordPress MySQL database is running up, still running. Okay, so in this way we can use it for the you can run either stateful and stateless application. So in the next video we will talk about the jobs and cron job, which is very interesting topic, and it is very useful in the traditional automation world. So let's talk about it. Thank you guys.